Okay, welcome back. Now it's time to reintroduce grams because we're going to introduce them to our conversions for today. So you need a periodic table handy and you need a calculator for today's lesson for it. So let's get started. Now this is a molar mass reminder. We've done it now twice this year. We did it when it was just simple atoms like finding the molar mass for potassium. So if you look on your periodic table for potassium, you would see that we have 39.10 as its molar mass. And remember that it's grams always per 1 mole, so that would be 39.10 grams per 1 mole for it. So notice that the number will always stay with grams for it. Now don't forget that if you have a compound, let's say like water, is that you have to add up each piece of the compound, which is two H's. So we have H equals 2 and 1 O. And we're going to see that H is 1.01, which gives us 2.02. And then O is going to round to 16, which gives us 16. So we would see if we add up all the masses, we'd have 18.02 grams per mole for it. So that's just a molar mass reminder to help us go through as we now introduce grams into our conversion. So if we're looking at a grams to gram conversion, that means we're going from grams of A to now grams of B. And this is the more practical part of it, but you have to know what a mole conversion is before we can introduce this grams to grams part for it. So always start with your given. That's going to be the number from the problem here. So don't forget that's going to come from our problem and it's going to lead us to where we're going to start with for it. Now, because this is stoichiometry, we have to remember we need that balanced chemical equation to help us out, but not yet. The first part is going to be our molar mass, which we're going to get from our periodic table. So then our grams A and grams A would cancel out and we're to moles. And this conversion looks familiar because we've already done it before this year. So now the new step that we're adding in is our mole ratio. And that's what we've been practicing previously. That's when we're going to use our coefficients from our balanced chemical equation as our mole ratio. Now remember, we need mole A to cancel out to lead us to our unknown of B. Now don't forget, we get them from our balanced chemical equation for our coefficients. Now this one in the second step will always be 1 because remember when we looked at molar mass, it's grams per 1 mole for it on the periodic table. Okay, and then our final step is going to be molar mass, but the reverse. So then our moles to moles can cancel out, and we're left with the number of grams of B for it. So this is a 4-step conversion. Wow, that's a lot of math happening there. But remember, we still have our time symbol in between, so we need to multiply the entire top, multiply the entire bottom, and then we're going to divide by top to bottom to get our answer of grams per B. Now, don't forget, whenever we're getting number of grams, we need our periodic table handy and ready to go for this molar mass. So let's try our first example. I'm still going to go with the same colors as I did before. So wherever we see A, I'm going to do blue. And then whenever we transition to B, I'm going to do the yellow for it. So notice that it goes blue, 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 and then we have yellow, 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 yellow. So let's head back to that slide, and we're going to color it in to help us for it. So we're going to have A, 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 and you can do this along with colored pencils or a highlighter, and you can choose what colors it is. So the color coding is going to help us go through what we need for our periodic table. Now remember, your given's always 1, so I'm going to place my 1 there. Let's read our problem and identify what our A's and B's are. So you are given 12 grams of cobalt, CO. How many grams of CO2O3 are produced? So remember, our given A is going to be the number in the problem. We're going to find it up in our conversion, highlight that too. And then our unknown is how many grams of CO2O3 there is. So we find CO2O3 up here. And then we'll notice that we don't care that there are 3 O2s for it because we're only looking at our A to our B. So now let's start filling in our given and see where it takes us. So our given is going to be that number in units. So we're going to have 12GC. So then we need GC here. So we need our periodic table out, and we'll see that carbon has, or cobalt. Oops, sorry, I was going on the carbon train already. Yeah, so we'll see that cobalt is 58.93. So 58.93 goes on the bottom. Remember that grams is always per 1 mole. I'm off on this Tuesday morning. So we're going to have 1 mole of CO there. So notice that our gram and our gram cancels out, and we've done conversions like this before. So now this is our pivotal point where we're going to transition from our A to our B. So we need to look at those coefficients. And we'll see that this is pretty cool. We have 2 moles of cobalt on the bottom, and we actually have 2 moles of cobalt 3 oxide on top. Now we can simplify it, but I'm going to do that at the end once I have all my numbers in. So notice again that our mole of CO cancels out. And we're going to keep following it down. And we'll see that we have mole of CO2O3, and we're trying to get to grams of CO2O3 here. So remember, our final step and our second step is the periodic table. So right now we need to do the molar mass. So I'm going to do it on the side over here. We have CO equals 2, and we have O equals 3. Now remember, when we do molar mass, it's just of the formula, not with the coefficient, because the coefficient is right in this mole ratio. So we don't have to contribute that to the mass that we see. So cobalt was 58.93, and we saw oxygen is at 16. Now I've run out of space, so follow along on your calculator. If we do 2 times 58.93, we get 117.86, plus 3 times 16 is 48, and then we'll add those two together to get the final molar mass. So 117.86 plus 48 gives us 165.86, and that's the number we're going to put in our final line here. So 165.86. Now notice that our mole and mole will cancel out. And what kind of mole is it? It's just 1 because it's molar mass. So now we're to the end of it. We can simplify this to a 1, simplify this to a 1, and that means we're going to multiply the top to get our number. So 12 times 1 times 1 times 165.86. So we're going to multiply that by 12, and oh, we got a big number on top, 1990.32 on our top. Then we do the bottom. We have 58.93 times 2 times 1 is going to be 58.93. So we'll divide that top number by that bottom number, and we get a very long number. We got 33.774385. So now go back to your problem. How many sig figs are in 12? No zeros, nothing fancy. We see that it's 2 sig figs. So we're going to count over 1, 2. Will 7 round 3 up? Yes. So we would see our final answer is 34 grams of CO2O3. And wow, these grams and grams take up the whole screen for it too. So if we're doing grams to grams, we're going to see that we have 4 steps, but it always follows the same pattern. We have our grams given, molar mass per 1 mole, mole ratio from our balanced chemical equation, and then we end by multiplying by molar mass. So what this means is that if you had 12 grams of our given, you would make 34 grams of our product for it. And that's reaction stoichiometry for you. Thanks for watching.